series circuit. If I consider the entire this as a one resistor, then this will become the series circuit. Okay? That's why I have considered this as a entire 1000 ohm resistor. Now the potential difference across the 500 resistor. Okay? We need to find out the potential difference across this 500 ohm resistor. Now again we know in the what happens in the series circuit, the potential difference split. Okay? So there are two combinations over here. There is one combination. This is the first combination. This one is the second combination. So potential will split across this and across this. Okay, we need to find out the potential across this 500 ohm resistor. Okay, and for that we will just use the Ohm's law. The current, what is the current flowing through this 500 ohm resistor? It is the same thing, that is nothing but we have just calculated, that is nothing but 0.012 ampere. Okay, so current flowing through the 500 ohm resistance remains the same. Okay, and that's why we can find out the potential difference across this 500 ohm resistance by simply using the Ohm's law. Here Ohm's law is what? Here in this case Ohm's law is nothing but V is equal to IR. So I is nothing but 0.012 into the resistance value is nothing but 500, and that is coming out to be 6 volt. That is coming out to be 6 volt. I will write down over here again 6 volt. So see, I have just used the Ohm's law. We just need to know the current flowing through this 500 ohm resistance, and current throughout the circuit remains the same, and that is 0.012 ampere. The resistance value is already given, so V into I is nothing but the voltage. So voltage is split across this combination and this combination. So in this combination we have got the value of how much? 6 volts. So of course the voltage across this combination is again the 6 volt, because 6 plus 6 will become the 12 volt. Okay, so here the voltage across 500 resistor is this 6 volt. Okay, so I hope you understood this. Now this is the part B of the question. The temperature of the thermistor is increased so that its resistance decreases. Okay, state the effect of this change in the resistance of the resistance on the current through the 500 ohm resistor. So basically what is happening over here, when we are increasing the temperature of the thermistor, I told you depending on the temperature the resistance may increase or decrease. In this case the resistance is basically decreasing. So resistance is decreasing, the thermistor resistance is decreasing. So what happens to the current that is flowing through this 500 ohm resistor? That is our aim. So if the resistance of this thermistor decreases, okay, if the resistance of this thermistor decreases, what will happen? The entire this parallel combination resistance will decrease. Okay, entire this combination will decrease, and that's why entire, if you talk about the entire resistance of the system or entire resistance of this circuit, that will also decrease. Okay, if you decrease this value, this will also decrease. And so if the total resistance of the entire combination decreases, what will happen to the current? Current in the circuit will increase, because the same current is flowing through this 500 ohm resistor and same current is flowing through this combination of this thermistor and 1000 resistance resistor. Okay, so we can write down the same thing. First of all, we can write down the resistance of the parallel combination decreases or we can also write down like the resistance or write down the total resistance of the circuit. Total resistance also decreases. Okay. So if the parallel combination, I just told you that if the parallel combination resistance decreases, the total resistance of the circuit also decreases. And if the total resistance of the circuit decreases, what will happen to the current? So the current, you can write down here, current through 500 ohm resistor will increase. Okay, the current through 500 ohm resistor will basically increases. Okay, so it is just in accordance with the Ohm's law. What happens if the uh, current decreases? Sorry, if the resistance decreases, current will increase. This is according to the Ohm's law. So I hope you understood this problem. Now we are ending up our numericals over here. Thank you so much.